Okay, I'm sure that last video left you wanting more. I mean, who doesn't just enjoy converting moles to grams and stuff all the time? So I'm going to do a few example problems for you. Example 1. What is the mass of 3.25 moles of H2SO4? Question. So we have to identify what steps we're going to take to solve this. So first we need to find the mass. So that means we want our final answer to be in grams, kilograms, milligrams, some sort of measurement of mass. We're going to go with grams here because that's what is typically used in this situation. And then we've got 3.25 moles of H2SO4. So to go from moles to grams, we have to know what the molar mass of H2SO4 is. So our first step is to calculate the mass of H2SO4. So H, S, and O. We need to look up the molar masses of each of those. If we go to our periodic table, hydrogen, it's here, has a molar mass of 1.00784. Sulfur has a molar mass of 32.065. Let's write that to where you can read it. And oxygen has a molar mass of 15.9994. Okay, so we have 2 hydrogen here, so we need to multiply this by 2. We've only got 1 sulfur, and we have 4 oxygen, so we're going to multiply that by 4. So 1.00784 times 2 gives us 2.01568. Sulfur, multiplying by 1, no need for a calculator there. And oxygen, 15.9994 times 4 equals 63.9976. So we're going to add all those numbers together. So 63.9976 plus 32.065 plus 2.01568 equals 98.07828. Grams per mole of H2SO4. So now that we know what our molar mass of H2SO4 is, we can do the calculation and take our 3.25 moles and multiply by 98.07828 grams for every 1 mole. And that will tell us how many grams we have of H2SO4. So we're going to take our final number here, we're going to multiply by 3.25. We get 318.75441. That was correct, right? 75441, yes. Okay, now we don't round to the very end of our problem, but then we see we have 3 significant figures in our problem. All of our numbers here had well more than 3 significant figures, so we need to round this to the 3rd significant figure. So our final answer is going to be 300, and this 8 is going to become a 9 because of the 7 making it round up. 19 grams of H2SO4. Example problem number 2. What is the mass of 4.35 times 10 to the negative second moles of zinc chloride? So again, just like last time, we need to find what our mass of zinc chloride is. So Zn NCl. Let's go to our periodic table, look up the molar mass of zinc. Zinc has a molar mass of 65.409. And then let's look at chlorine, which I'm pretty sure is 35.453. Yes, 35.453. We have 2 of those, so we need to multiply that by 2. So we are going to get 35.453 times 2 plus our mass of zinc, which was 65.409. And that equals 136.315. So that's grams per mole of zinc chloride. Okay, so now we have 0.435 times 10 to the negative second moles. 4.35 times 10 to the negative second moles. And we need to multiply that by 136.315 grams for every 1 mole. Our moles will cancel out, and we will end up with grams as our final number. 136.315 times 4.35 times 10 to the negative second means that our number should get smaller. We do not have a full mole here. We're really looking at 0.04 moles. So we're going to take our 136.315 and we are going to multiply by 4.35 times 10 to the negative second. And we get 5.9297. I can stop there because that's going to give me enough numbers to round, because we're going to have 3 significant figures, because once again we have 3 in our problem and we have 5 from both of our molar masses that were given to us off the periodic table, so we're going to have 3. So our final answer is going to be 5.93, because that 9 is going to make the 2 round up, grams of zinc chloride. Now let's go the other way for a couple of examples. How many moles are in 22.6 grams of silver nitrate? So exact same thing. We can't solve this until we have the molar mass of silver nitrate. So we need Ag, we need N, and we need O. We just used O, it's 15.9994. We got 3 of them, but we need to look up our masses of silver and nitrogen. So silver has a mass of 107.868, 107.868, and nitrogen has a molar mass of 14.0067. So we are going to add all those numbers together. I'll start with the oxygen, multiplying it by 3. So 15.9994 times 3 equals, and then we are going to add our nitrogen and our silver. So 14.0067 plus 107.868. And our molar mass of silver nitrate is 169.8729. 0.8729 grams per mole. So we know we have, from the problem, 22.6 grams of silver nitrate, and we need to figure out how many moles are in that amount. So we are going to take our 22.6 grams. We need to get rid of grams and we need to get moles. So we're going to multiply by 1 mole for every 169.8729 grams. So really we're dividing by the 169 number. And then we'll be left with moles. So 22.6 divided by 169.8729, that's the right number, is going to equal 0.133040. 0.133040. And then we go here. Once again, we've got 3 significant figures, so we're going to round this to 0.133 moles of silver nitrate. And our final example that we're going to do today is how many moles are in 6.5 grams of zinc sulfate. So again, we need to solve for the mass of zinc sulfate. We've already looked up all those numbers. Zinc, sulfur, and oxygen. If we go back, zinc was 65.409. Sulfur, we looked that up in our first problem, was 32.065. And oxygen is 15.9994 times 4, because we have 4 of them. And we need to add all those together. So just like last time, I'm going to start with oxygen. 15.9994 times 4. And then we're going to add sulfur, 32.065. And zinc, 65.409. And we get 161.4716. 161.4716 grams per mole. Now we have 6.5 grams, 50 grams of zinc sulfate, and we need to multiply it by 1 mole, because that's what we want to get, and we need to divide it by however many grams are in a mole, which is 161.4716. So our grams will cancel out, we'll be left with moles. So we're going to take our 161.4716 and multiply by 6.50. We get 1,049. We are not going to multiply. I misspoke. we are going to take our 1647161, and we are going to divide, because, well, that's what this says. It says multiply by 1 and divide. And we need to take our 6.5. I'm all the way backwards. So we are going to take our 6.50 and we are going to divide by 161.4716. Yeah, that looks like a better number. And we are going to see that our answer is 0.040254. 0.040254. And then we are going to round to significant figures, which once again we have 3. So we are going to find that is 0.0. Neither one of those zeros are significant, they're just placeholders. So here's our first significant figure, 40, and the 2 will become a 3 because of this 5. So 0.0403 moles of zinc sulfate.